today we talk about perfect number. Okay.
Perfect.
Perfect number.
What is a perfect?
Okay, so first of all, remind me, what kind of numbers have you learned so far?
Ugly number, happy number,
Sad.
and confusing number.
Well done.
Invalid.
Okay, so happy number. What's happy number?
Is you just square the digit
Until you
get
get
one.
one.
Yeah, and what's the confusing number?
Is when you turn it upside down.
Yeah.
It's still a number, but it's different.
Okay, and what's
No,
the
first
and what's the another one you talk about?
Ugly.
Ugly number. It only has the factors, the 2, 3, and 5, right?
Yeah.
Divisors. Yes. Okay, so this perfect number is something to do with the divisor as well. So, for example, 28. Yeah.
Is 28 a perfect number?
Yes. Why is that? Because
Why?
28 the divisor. 1, 2,
4, 7.
4, 7, 14. Okay, but not 28, not excluding itself. Okay. So what's the divisor? Add it together. What's this? 3, 7, 10.
28.
Yeah, 20.
It is 28.
7. Yeah,
It is
yeah.
28 and.
Yeah, is it? So this is the perfect number. Do you get it?
Oh.
It's divisor. Look, this. What's divisor? So this number can be divided. Yeah, 28 divided by 1. 28. 28 by 2. Yeah, 4, 7, 14. You got it?
Yes.
Yes. So any thoughts how we doing this? Any idea how are we doing this?
So we just write what are the numbers
So we iterate, yeah?
divided by
Yeah.
28.
Wait,
Then they must equal 28.
so we check.
The number.
Yeah. So first of all, we need to go through these numbers. Yeah. And to find out if it can be divided, if it's a divisor. If it's a divisor, then we add the number. Yeah? And then we finally check if this number is itself is same, yeah? So
A
let
prime
me,
number is definitely not a perfect.
sorry?
Is
A prime number is definitely not a perfect.
Well done, yes. Yes, because it cannot be equal to itself, yeah? That's very, very well done. A prime number cannot be a perfect number. Of course it's not. Is 1. 1 is a perfect number, yeah?
Yeah.
2?
No.
No. No. Okay, so 1 is a very special case. So is 1 a perfect number? Maybe. Maybe yes. Okay. So 0 is not a perfect number, right? Yeah. Negative numbers, not perfect number. Yeah.
Yeah.
Okay. So let's write this. Define perfect. Perfect. What's perfect? Good. Very good.
Yeah.
What's the opposite of perfect? I don't know. Okay. N, yeah? Okay. If n smaller equals 0, return what? If n smaller than equals 0, return what?
False.
Well done. Return false. Okay, so now we sum this digit sum the number in the s, okay? S is first of all 0, okay? So for I in range 1, start from 1, right? Yeah?
The numbers start from 1. Numbers
So-
start from 1.
So do we need to go above half? Like if it is
No.
because 28 it's impossible to find a divisor that is bigger than half of it. Right? Am I right? Any number like 100 cannot be divided by some number more than 50, right? Yeah, you got it? So
But 50.
this n divided by 2 but plus 1, yeah? Because up to this, okay? Got it? What's missing here?
Column.
You're not even looking. How do you know it's missing column? Huh?
I know.
I know. Every time I.
The brain.
Okay, so now if what? If num divided by I, what should I put here? If it can be divided, so what how do you represent if it can be divided?
You put it in something.
If n, what's this percentage? What does that mean?
I think it's something like I don't know how to explain.
Modulus, yeah?
Yeah.
Divide
Modulus.
and yeah, modulus and
Modulus.
and what should I put here? 0. What should I put here? What should I put here? What should I put here?
Equals.
Equals. How many equals?
2.
2 equals. And what's missing?
Color.
Okay, so now what should I do here? What should I do here? What should I do here?
Return something.
No.
S.
S, yeah, S what?
Plus.
Plus what?
Equals 1.
I.
Okay.
Okay, so we plus all the divisor, yeah?
Yeah.
We plus all the divisor and return
S. Equal
equal what?
none. None. None.
Okay, what's the term complexity?
I win.
Oh, and yeah, even though this number goes through just half of it, but it's still ON, it's linear. Yeah, you got it?
Yeah, we
Yeah.
end.
Let's no. Oh,
What have
oh,
you got? Column.
Okay, so can we make it better? Can we make it better? Do you notice something? Do you notice something? Look, Eric, look. This 28, yeah? 28. 1, 2, 4, 7, 14. Okay? And possibly 28 here. So what do you notice? What do you notice? 2 and 14. 4 and 7.
They all
1 and 28. So what does it mean?
times up together 28.
Yes, so if I found a 2 factor, that's a 2, yeah? There must be another factor which is 28 divided by 2, am I right? Yeah? If I find a 4, what does it mean? I also find 28 divided by 4, am I right?
Yeah.
Because look, if I find a divisor d, you also find something n divided by d, and then you times it together, you become n, right? Yeah? You got it? Yeah? So what does it mean? I don't need to go through to half. I only need to go through
Smiley face.
I only need to go through the numbers when I times I square is smaller than equals n, right? Got it? So look, I square smaller or equals n. So what does it mean? What does it mean? It means I smaller than square n. Alright? It's the same thing, yeah? Yes?
N squared.
Okay, so look, so it will be faster, okay? So let me write the code, okay? Look. Yeah,
It's fine.
this is the same, okay? So now I still have s equals 0, okay? Here, right? Right? To add to store the number of to store the sum of the divisors, yeah, divisors. So now I will be equals to 1 first, okay? So now wire I times I, okay, is smaller or equals n, right? Yes? Because now we are checking if I is smaller than, right? Then what should we do? If n divided by I can be divided, yeah?
Yeah.
So now what should we do? S plus equals I. Now I found the divisor I, yeah? So what's the other part? What's the other divisor?
I divided by
Huh? N divided by I, right? Yeah?
So
So look, but
I'm confusing.
but look, there's a very special case, like 16. Yeah, 16. I found a 4. What's the other half?
4.
Yeah, it's the same, yeah?
Yeah.
But obviously you can only add 1, right? Yeah, do you get it? Because when the other n divided by I is also the same, you can only add 1, right? So here, if I times I not equals n, right? Yeah, Eric? Then I can add s plus equals n divided by I, right? Yes? Eric? Eric, what you doing? And look, and then I need to increment I plus equals 1. Okay, so Eric, so now what should I return here? Because I have I and I also have n. Look, because I added I and I also added n. So what does it mean? Look, when
S. Return something.
look.
Return S.
Look. I equals 1, n is 28, yeah? Alright?
Yeah.
Look,
And
I
it's
equals
not
1.
always 28.
Listen to me. If n 28 modulus I equals 0, I add the 1, right?
Hmm?
And if 1 times 1 not equals 28, right? It's not equal, right? So I also added 28 divided by 1 is 28. So do you see it? I also added one more n, right?
Yeah.
So I should check return s minus s what? S minus n equals n, right? Or s equals n plus n. It's the same thing. Do you see why this is? I need to subtract n from s. Do you get it? Why? I just told you why.
Why? Because
Because what? Because what? When I equals 1, and I added one more here, n. You see?
yeah,
Do you get it?
yeah.
Can you repeat?
I equals 1 and then s at equals n divided by I.
Yeah, so but then that's where this n is from. Then I need to subtract n. Then if it's the sum equals to n, then it's a perfect number. Do you get it?
Mhm.
Yeah?
Yeah.
Does it make sense? Do you see Lay's code? Which part you don't understand? Which part? What's the term complexity?
O n.
What's
Square root. N.
square root
Square
of?
root.
Why? Because this I times I smaller than n. So what does this mean? I square smaller equals n, right? Yeah? So if I square root of both sides, right? So what does it become? I square square root is I, right? Yeah? So I smaller than square root of n, right?
Mm.
Yeah, so if I is 100, I only need to iterate how many times?
50. No, 10.
10. Yeah, square root of 100 is 10. So previously I need to iterate how many times?
50.
Yeah, so which is better?
10.
Obviously 10 times is better. Yeah, the computer needs 10 times compared to needs 50 times. If this n is bigger, like if n is 1,000, maybe
10,000?
10,000. Yeah, if it's 10,000. 10,000, okay? So
Me?
previous the first method, how many times? 5,000 times, yeah?
And
And this equivalent, how many times?
100.
100 times. You see? Now it's almost 50 times difference. Do you get it?
Mm.
Yeah. So when n gets bigger, this equivalent is faster, a lot faster than the. When n is smaller, there will be no difference. For example, like 50 compared to 10. Yeah. This is 5 times, and then now this 5,000 compared to 100. This is 50 times. You see? You see the difference? Yes? Yes? Okay, so now let me you want to take another look before I erase some of it? Eric and Ryan? Ryan, you want to help? Ryan? Okay, Eric, you want to take a look?
I don't know.
You don't know.
I don't know.
Just take a final look and let me erase some of it, okay? Close your eyes.
Depends on which one.
Yeah.
I think it's going to be the bottom half.
Ryan, you want me to?
A bit.
Okay. Now
I'll
close
be
your
very
eyes.
bad.
Okay, so this bit.
S.
You write it.
I think.
If I times I is not equals to n, what happens? We need to add it. Add it. Yeah? Yeah? What should we add?
N or S?
S, we are checking the S. S, yes? What are we doing there?
We're adding.
Adding what? Adding what? Adding which factor? Plus, equal, yeah?
Yeah.
Adding what? I or n divided by I?
N divided by I.
Why is n divided by I?
Okay, so I.
Come on, be
N
confident.
divided by I. Okay.
Yeah. Look, we are adding I here. If we find a 4 and we need to add a 7, right?
Yeah.
Do you get it? Okay. Okay, that's it.
Bye.
Okay, see you tomorrow. See you tomorrow.
Bye.
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 See you tomorrow.
Bye.